All right, so NASA chief scientists, they're giving us some serious, they're saying there's an asteroid that's possibly gonna hit planet Earth, man. That's a scary thought. Honestly, that's a scary thought, knowing that there might be an asteroid that's gonna hit planet Earth within our lifetime. Like, if you're watching this video, it's a possibility. So yeah, if you guys are new to the channel, become part of the family, man. Hit that subscribe button, give the video a like, that helps me out a lot. And yeah, let's get into this, man.
This episode was made possible by Brilliant.
Brilliant.
Throughout history, the thought of a massive space rock hurtling into Earth has got quite a lot of people nervous. It's understandable that people are
yeah, I would be nervous, guarantee. All of us watching right now will be nervous.
Naturally afraid of asteroids. If one were to really make contact with our planet, it could create massive tidal waves, a brand new ice age, and an explosion that is unparalleled in the course of human history. Even though the movies like to show asteroids creating havoc for humans, the idea is not just some work of fiction by movie studios. The truth is that asteroids do pose a real, credible threat to all of humanity. And to make things even worse, NASA has already detected massive asteroids that are on a straight path for Earth. This is where NASA's DART mission enters the picture, the first planetary defense project to test a method of deflecting an asteroid on course with our home planet.
Okay.
So, what does DART do? When will it be up and running? And most importantly, how will it save us from the biggest threat to humanity?
Hopefully they got backup plans for this DART too. What if they fire this rocket or something and it hits but doesn't do anything? I hope they have more than one. That's all I'm saying.
October 22nd, 2021. This was the day an enormous asteroid named 2021 SM3 came flying by Earth at breakneck speeds. With a diameter of around 525 feet, this space object is even bigger than the Great Pyramid of Giza in Egypt. Perhaps the most frightening part about this experience was that scientists were only able to detect the object 1 month in advance to its nearby passing, meaning that if its trajectory was just slightly changed towards Earth, we would have had no way of stopping its destruction.
You see, this is why 1 month, and this was just last year, bro. Last year. I'm telling you, these scientists, I don't know, man. I feel like if they know an asteroid's gonna hit planet Earth, they wouldn't tell us. Straight up, they would not tell us. We'll just hear a loud boom, and that'll be it. That'll be it. Be like, yo, and then we'll look out our window, and yeah, there's nothing you can do. There is nothing you can do. Just pray and hope for the best.
This is just one of the many close calls that Earth has each year with asteroids. So it's no wonder why NASA has made it a priority to create a reliable system to prevent a horrific collision. Formerly titled the Double Asteroid Redirection Test, NASA's DART probe launched only 2 months after this close call while riding atop a SpaceX Falcon 9 rocket. The mission will all come to a head later next year. That's when the 1,210-pound spacecraft will collide with a minor asteroid dubbed Dimorphos at a speed of roughly 4 miles per second. This will happen in late September or early October 2022 and will hopefully modify the space rock's orbit around.
Wait, hold on. So this already happened recently. I'm gonna have to do some research on this and watch a couple of videos about this because this just happened like last month.
Partner Didymos. After the collision, astronomers down on Earth will measure the difference to see how efficient this kinetic impact approach of asteroid deflection is. If the results are substantial, this might become the tactic mankind may use in the future if a rock lines up Earth in its sights. Ideally, the impact should shorten Dimorphos's orbit by several minutes, although the exact amount is subject to change. DART will prove to NASA that a spacecraft can navigate itself to a target asteroid and collide with it on its own. Now, how does DART work, and what sort of next-gen technology has NASA equipped it with? The DART spacecraft is tiny compared to others in NASA's arsenal.
Oh, that's it?
The spacecraft's core is a box that is just a meter wide on all sides, with 2 roll-out solar arrays that give it a span of roughly 40 feet. DART's electronic propulsion technology uses a constant flow of charged ions to deliver a mild push. To get going, The spaceship will circle around Earth many times using its electronic engine to gradually build the necessary speed to break out from orbit. It will then start the long journey to Didymos, potentially passing another asteroid named 2001 CB21 along the way. DART actually has only one piece of science equipment named Draco, a high-resolution camera that also serves as a navigation system.
Okay.
It's inspired by a camera on NASA's New Horizons mission, which famously flew past Pluto years ago. DART will launch an Italian space agency-built CubeSat to witness the impact 5 days before it arrives. The primary spacecraft will be too far away from Earth for flight controllers to manage in real time, so 4 hours before impact, it will convert to an autonomous navigation mode. Draco's images will aid the spacecraft's computer in distinguishing between Didymos and Dimorphos.
My concern here is automated, right? What happens if these guys try to like veer this thing off course, and in that process, it actually makes it head straight towards Earth? Have you guys ever thought about that? That is some scary shit, man, right? What if this actually comes right towards us now because they accidentally try to veer it off course, but now it's coming straight towards Earth? Or it hit another asteroid, and that asteroid gets redirected towards Earth. Bruh, think about that for a minute.
Allowing it to navigate toward the latter. Using a very cutting-edge guidance, navigation, and control system, along with algorithms called Small Body Maneuvering Autonomous Real-Time Navigation, or
Fancy-ass
SmartNav,
names.
the
Fancy
DART
names.
craft will be able to tell the difference between the two asteroids, allowing it to zero in on its final destination. All of this planning and projecting and navigating will occur within just 1 hour of impact. The target asteroid is about 6.8 million miles from Earth, far from the reach of our scientists on the ground. That means that all of this will truly be autonomous. After all that preparation, it'll be over in seconds. DART will collide with Dimorphos, changing the orbital period of Dimorphos around Didymos from 11.9 to 11.8 hours, a difference of only 4.2 minutes. Dimorphos will move closer to Didymos as a result of this. All in all, the project will quickly send back the results that will be analysed again and again by the brilliant minds at NASA. The best-case scenario will give the agency a strong, reliable way to fight off an asteroid hurtling towards Earth. The worst-case scenario will send them back to the drawing board yet again. Astronomers will be able to compare data from Earth-based telescopes before and after DART's kinetic impact to see how much Dimorphos's orbital period altered. This is the critical metric that will inform NASA how the asteroid reacted to DART's deflection operations. The European Space Agency's HERA mission will form a follow-up analysis of Didymos and Dimorphos a few years after the impact, providing more data and results for scientists to work through. The idea of deflecting an asteroid isn't a new one, but it's one that NASA has been looking to investigate for a long time. They just needed to find the right asteroid system to send the craft to. These asteroids have a certain speed that is really attractive to NASA, especially for a test like this. Because Dimorphos orbits Didymos at a much slower speed than other asteroids, the results of the DART experiment can be easily measured.
But wait, what about, like, I know some of these asteroids have their own like gravitational pull. What if they send these things out, these Dimorphos or these little spaceships out, whatever, and it gets pulled into the asteroid's, gravitational pull and like flings it off? Anyone? I don't know. I'm not no NASA scientist, but I'm just saying that's a possibility. I hope they thought about that. All right. So if NASA's ever watching one of these reaction videos or anything, and like, yo, we never thought about that, but I'm pretty sure they did, because there's some smart ass people at NASA. But that's just something for us to think about. Okay, as well, just putting it out there. It's out there.
Dimorphos was chosen for this trip because its size is comparable to asteroids that potentially threaten Earth. Yet the twin asteroid system does not represent a direct threat to Earth itself. The DART spacecraft will not destroy the asteroid. Instead, it will give it a little nudge and alter its trajectory around the bigger asteroid. This implies there's no way to change the asteroid's course to make it more dangerous. Dimorphos's speed will barely alter by around 1% when it circles Didymos due to the rapid impact. Although this may not seem like much, it will shift the Moon's orbital period by more than a minute. Every 11 hours and 55 minutes, Dimorphos completes an orbit around Didymos. According to the specialists observing from the Johns Hopkins Applied Physics Lab, if the hit is effective, it will shift the period by at least 73 seconds. Measuring the momentum transfer between the spacecraft and Dimorphos will reveal how much energy is required to alter an asteroid's trajectory. As a result, if an asteroid on a collision path with Earth is detected one day, NASA will now know how much momentum is required to make the asteroid avoid Earth. It doesn't take a scientist to know that is very important information indeed. While there are now no asteroids on a direct collision trajectory with Earth, there is a massive population of near-Earth asteroids in different forms and sizes. Finding these objects before they pose a direct threat to humans is critical to planetary protection. The concept behind them all is to alter the asteroid's orbital speed by a little amount. Changing the asteroid's orbital speed modifies the asteroid's orbit, so it won't be in the same spot to strike Earth in the future. Although this entire mission will take a long time to complete and be fully analysed and studied, it's already progressing quite well. The DART spacecraft opened the round door covering its Draco telescopic camera on December 7, 2021, and provided the first photograph of its position. A dozen stars placed against a black sky can be seen in the photograph, which experts confirm is the junction of constellations Perseus, Aries, and Taurus. There are so many asteroids floating through the deep reaches of space. There are truly millions out there and thousands that could someday pose a threat to our existence on Earth. In the end, what DART will attempt is the smartest, surest way to stop an asteroid from smashing smack dab into the middle of planet Earth. Yes, there are many things to be afraid of in deep space, but DART might be what stops the biggest threat of them all. If you want to get a better understanding of space and science, then you will love this video's sponsor.
This makes me kind of nervous, okay? Hearing stuff like this makes me hella nervous. But till then, you know, we'll be looking up at the stars, up the skies, and we'll see what happens. All right, so anyways, we're out. Like, subscribe, all that stuff. Bye.